Picture this. You're just walking down the street, right? And you happen to overhear this exact real-world conversation between two friends, Rohit and Ajay. Rohit looks right at Ajay and says, "Give me 100, I shall then become twice as rich as you." But Ajay just smirks and fires back, "Well, if you give me 10, I shall be 6 times as rich as you." I mean, it literally sounds like a riddle from a detective mystery, doesn't it? You know exactly how their money relates to one another based on these two little clues, but how much cash do they actually have in their pockets right now?
So think about it for a second. How do we actually solve this puzzle without just guessing numbers forever? I mean, you could sit there plugging in random amounts of rupees. Maybe Rohit has 50 and Ajay has 100. Nope, that doesn't work out. Honestly, it's virtually impossible to solve this by pure guesswork without giving yourself a massive headache. And that raises the stakes, right? We need a real, systematic tool, a method that cuts right through the confusing dialogue and just gives us the undeniable truth.
Well, welcome to The Explainer. Today, our big goal is to take what seems like this complex, intimidating math concept and turn it into your own personal, simple secret decoder ring. We're going to master the art of cracking simultaneous linear equations, and I promise you, by the end of this explainer, you're going to look at riddles exactly like Rohit and Ajay's, not as frustrating guessing games, but as perfectly solvable puzzles.
Okay, so here's our roadmap for today. First up, we've got the two-variable mystery. Then, Method 1, substitution. After that, Method 2, equating coefficients, and Method 3, cross-multiplication. Finally, we'll wrap up with solving real-world puzzles. Let's get into it.
All right, Section 1, the two-variable mystery. We are officially hunting for unknowns. You see, in the world of algebra, we're tracking down two very elusive suspects, and we usually call them x and y.
So what exactly are we dealing with? The formal definition of simultaneous linear equations is simply two linear equations containing the same two variables that are satisfied at the exact same time. But here is the absolutely crucial point. One clue, or one equation, is literally never enough when you have two suspects. If I just say, hey, x plus y equals 7, well, x could be 3 and y could be 4, or x could be 1 and y could be 6. The possibilities are endless, right? We need two intersecting clues that point to the exact same truth at the exact same time. That is the whole reason they're called simultaneous.
Moving on to Section 2, Method 1, substitution. So how do we force these two clues to give up their secrets? Well, we use this precise mathematical scalpel to carefully isolate one of our suspects. That way we can figure out exactly who they are.
The logic here is just beautifully simple, and it breaks down into 3 concrete steps. Step 1, you take one of your equations and manipulate it to find the value of one variable in terms of the other. Basically, you just get x or y all by itself on one side of the equal sign. Step 2, you take that new little package you just created and substitute it right into your other equation. Now suddenly you only have one suspect to deal with, and you can solve for a real, actual number. Finally, Step 3, you take that real number and substitute it back into your very first step to catch that remaining unknown.
Now, as you'll see here, this brilliantly illustrates the whole concept in action. Check out the alternative method section right in the center. We've got our two clues, x plus y equals 7, and 3x minus 2y equals 11. In Step 1, we take that messy first equation, wrap up x nicely so that x equals 7 minus y. Then we just drop that entire package into the second equation exactly where the x used to be, and boom, it forces the equation to only have y's in it. We solve it, find out y equals 2, and then plug that 2 right back into our first clue to effortlessly find that x equals 5. The scalpel works perfectly.
Let's look at Section 3, Method 2, equating coefficients. Now, if substitution is a precise scalpel, think of this method as a hammer, because sometimes equations are just ugly. Neither x nor y is easy to isolate, and trying to use a scalpel would just create messy, complicated fractions. That is exactly when you bring out the hammer.
This method is all about forcing a direct confrontation between our two suspects. Step 1, we literally multiply one or both of the entire equations by a number so that the coefficient, the number attached to our suspect, becomes exactly the same in both clues. Once they match up perfectly, Step 2 is to simply add or subtract the two equations together to completely cancel that suspect out. It's a total elimination. Then, Steps 3 and 4 are just like before. Solve what's left and substitute back.
I really want to guide your attention to the subtraction step here. We start with 3x minus 4y equals 10 and 5x minus 3y equals 24.
A substitution scalpel would be an absolute nightmare here. So we use the hammer. We multiply the first clue by 5 and the second clue by 3. And look at the resulting equations, 15x and 15x. We force the numbers to match. Now, by simply subtracting the second equation from the first, notice how beautifully those x terms just vanish into 0. The suspect is eliminated, leaving us a super simple equation to find y. Before we look at our final tool, let's just briefly compare the two we just learned, because it's important. You're going to want to pull substitution out of your toolbox when a variable is already isolated, or at least has a coefficient of 1, making it super easy to isolate. On the flip side, you want to reach for your equating coefficients hammer when the variables have messy, larger numbers, and dealing with fractions would just slow you down. Honestly, it's all about choosing the path of least resistance.
All right, Section 4, Method 3, cross multiplication. Look, I know the name sounds a bit intimidating and the formula kind of looks like a chaotic alphabet soup, but trust me, it is actually a simple, really beautiful visual pattern.
Because it relies on this visual pattern, it does require a very strict setup. Step 1, you absolutely must express both equations with everything on one side equaling 0. That's the ax plus by plus c equals 0 format you're seeing. Step 2, you pull out just the numbers, the coefficients and the constants, and write them in a very specific repeating order. And then step 3 is where the magic happens. You multiply downwards diagonally and then subtract the products of multiplying upwards. This strict organization makes the final calculation incredibly fast.
Now, what's really interesting here is that visual crossing arrows guide right in the middle. Just trace those downward and upward arrows with your eyes for a second. We line up the b, c, a, and b coefficients. Then, for the x denominator, you literally just follow the arrows. Multiply b1 times c2, going down, and subtract b2 times c1, going up. You do the exact same thing for y and the constant 1. It absolutely proves how visual and mechanical this mathematical tool really is. Once you memorize the physical crossing motion of the arrows, you can crack complex equations in seconds without ever having to isolate or balance a single thing.
Okay, Section 5, Solving Real-World Puzzles. We've officially filled our toolbox. We've got the scalpel, the hammer, and the pattern. So let's take these out into the field and actually translate some English into math.
The source material actually gives us 3 golden rules for doing this. First, identify your 2 unknowns and confidently label them as x and y. Second, carefully read the real-world statement to construct your 2 mathematical clues. And third, just pick your favorite algebraic method to solve it. Setting up those clues correctly, translating the English into algebra is literally half the battle. If you get the setup right, the tools will do all the heavy lifting for you.
Let's look at a really quick example from the text of this translation in action. Take problem 14. The present ages of A and B are in the ratio 9:4. Now, that's an abstract concept, right? But we instantly make A's age x and B's age y. So x over y equals 9/4. Boom, clue 1. Then it says 7 years hence, which is just a fancy way of saying in the future, so we add 7 to both their ages. X plus 7 over y plus 7 equals 5/3. Boom, clue 2. Just like that, these abstract concepts of age and time effortlessly become our highly reliable suspects x and y, locked into simultaneous equations. And that, my friends, brings us all the way back to the beginning. Our initial, supposedly impossible brain teaser. Rohit and Ajay arguing on the street about their wealth. So, are you ready to use your newly acquired superpowers on this? Let's crack the case once and for all. First things first, we follow our golden rules. Let Rohit's current money equal x, and Ajay's current money equal y. Now let's translate their confusing back and forth dialogue into perfectly structured mathematical clues. Rohit says, "Give me 100, so that's x plus 100. He goes on, "I shall then become twice as rich as you." Well, if IJ gives away 100, he now has y minus 100. So clue 1 is x plus 100 equals 2 times the quantity of y minus 100. Then Ajay fires back, "If you give me 10, so Ajay becomes y plus 10, he continues, "I shall be 6 times as rich as you." Since Rohit just lost 10, he is now x minus 10. This gives us clue 2, y plus 10 equals 6 times the quantity of x minus 10. And there it is. We have successfully translated everyday English into 2 undeniable mathematical clues. From here, you just simplify the clues, pull out either your substitution scalpel or your elimination hammer, and the final answer reveals itself with immense satisfaction. Rohit has 40 rupees. Ajay has 170 rupees. And let's just do a quick mental check to be sure. If Ajay gives Rohit 100, Rohit has 140, and Ajay has 70 left. And yeah, 140 is indeed exactly twice as much as 70. But if Rohit gives Ajay 10, Ajay jumps to 180, and Rohit drops to 30. 180 is exactly 6 times 30. The math works out perfectly, case closed.
So, the absolute most crucial point I want you to take away from this explainer today is that algebra isn't just about aimlessly moving letters around on a chalkboard. Not at all. It is a brilliant set of logical rules meant to decode the complex relationships in the world around you. You now have the scalpel, the hammer, and the pattern in your toolbox. So what real-world mystery are you going to solve with these tools next? Thanks so much for joining me on this explainer, and remember, keep looking for those hidden equations in everyday life.